In this video, we will talk about strategy design pattern. First, I will answer what is strategy design pattern. Then I will give you a general structure for strategy design pattern. Then we will talk about applicability, pros and cons, and how we can implement it. Then we will switch to the real examples. I prepared two examples for you. First one is sorting algorithm, which I prepared the UML diagram and I will explain the idea behind it. Then we will go to the Google Maps and we will try to code it as simple as possible. So, what is strategy design pattern? Strategy design pattern is a behavioral design pattern that lets you define a family of algorithms, put each of them into a separate class, and make their objects interchangeable. It's also known as policy pattern. We said it is a behavioral design pattern. So, what is behavioral design pattern? Those patterns are concerned with algorithm and the assignment of responsibilities between objects. Okay, now we have a general structure for strategy design pattern, a sample class diagram. Here you can see a context. The context maintains a reference to one of the concrete strategies and communicates with these objects only via the strategy interface, which is here. Strategy interface is common to all concrete strategies. It declares a method the context uses to execute a strategy, and these are the strategies. Concrete strategies implement different variations of an algorithm the context uses. Okay. Applicability. First is use the strategy pattern when you want to use different variants of an algorithm within an object and be able to switch from one algorithm to another during runtime. Secondly, use the strategy pattern when you have a lot of similar classes that only differ in the way they execute some behavior. Third one is use the pattern to isolate the business logic of a class from the implementation details of algorithms that may not be as important in the context of that logic. Fourth is use the pattern when your class has a massive conditional statement that switches between different variants of the same algorithm. All patterns have some advantages and disadvantages. So for the strategy design pattern, pros are you can swap algorithms used inside an object at runtime. You can isolate the implementation details of an algorithm from the code that uses it. You can replace inheritance with composition. You can introduce new strategies without having to change the context. And the cons are if you only have a couple of algorithms and they rarely change, there is no real reason to overcomplicate the program with new classes and interfaces that come along with the pattern. Clients must be aware of the differences between strategies to be able to select a proper one. Okay, how we can implement it. First step is in the context class, identify an algorithm that is prone to frequent changes. It may also be a massive conditional that selects and executes a variant of the same algorithm at runtime. The second step is declare the strategy interface common to all variants of algorithm. Third one is one by one, extract all algorithms into their own classes. They should all implement the strategy interface. Fourth step is in the context class, add a field for storing a reference to a strategy object. Provide a setter for replacing values of that field. The context should work with the strategy object only via the strategy interface. The context may define an interface which lets the strategy access its data. Fifth step is clients of the context must associate it with a suitable strategy that matches the way they expect the context to perform its primary job. So we can switch to the examples. First example is sorting algorithms. Sorting algorithms are used to rearrange a collection of items in a specific order, such as a numerical order or alphabetical order. There are many different sorting algorithms available, each with its own advantages and disadvantages, and different algorithms may be more suitable for different types of data. To implement this, the strategy design pattern can be used. The sorting system can define an interface for sorting algorithms with a set of methods that are required to sort a collection of items. Each sorting algorithm can then be implemented as a separate class that implements this interface. For example, the bubble sort class would implement the sorting algorithm interface and contain the logic to sort a collection of items using the bubble sort algorithm. The quicksort class would similarly implement the interface and contain the logic to sort a collection of items using the quicksort algorithm, and so on. We can add a lot of sorting algorithm here, like merge sort, counting sort, etc. This approach allows the sorting system to be easily extended with new sorting algorithms in the future by simply implementing a new class that implements the sorting algorithm interface. It also allows for more flexibility in the sorting system, as different sorting algorithms can be used for different types of data or different performance requirements. So let's go to the Google Map example. I tried to get a road from Ankara to Istanbul in Google Maps. As you can see, there are some options here which are available for us. First one is driving, then the transit, which is not available for now. The walking, cycling, and flights also are available here. Also, here is a best travel modes. I actually don't know how it works, but it probably calculates the options according to the money and time costs and then selects the best one. So we can use strategy design pattern here because at the end of the day, all of these options are actually returning some checkpoints. As you can see, here are some white circles, white nodes. These are the checkpoints. So these all uh, options are returning these checkpoints, and then the Google Maps render it and show in the browser. So we can write an interface for the calculating roads or road algorithms. Then we can implement it as separate classes, all of these options. So let's go to the coding part. Now I will create a new project, and let's name it as strategy design pattern created. First, I will start with creating the interface. I will name it as road algorithm as interface, and it will have a function which is public void get road, maybe, yeah, get road. I think we should give some destination and source from and to. Then I will try to create the options. First one was drive, which is implementing the iRoad algorithm. Okay, we will implement the function, and let's write a print function here to keep it simple. Road is calculated for driving from plus 2 plus 2. Yes, okay. Then I will create the other ones. Second one was walk. It also implements iRoad algorithm, implement methods. I will just copy this and change here as walking. Oops. Then the others, let's say flight. Implementing the method and changing here as flight. Yes. Let's create another one, or yeah, let's create the Java class. What was we have? Transit, yeah, transit. Implementing the iRoute algorithm. Implement the methods and for transit. Okay, now I will go and create a new Java class, which stands for Google Map. I can't write. Okay, uh, this Google Map class will have a private iRoute algorithm, which name is route algorithm, and it will have its setter. Let's generate a setter for it. Then also it will have a constructor, public Google Map, and defaultly I want to give this route algorithm as driving, because Google Maps does this whenever we get a route, it defaultly gives us a driving route. And then we will have a function public get route. It will have string from and string to. Then oh shit, yes, it should be void, and then it will run route algorithm dot get route with these from and to informations. Okay, we are done here. We'll go to the main part and create a new object for Google Map object. Let's say map, new Google Map, and then I will try to get a route from Ankara to Istanbul. Yes, let's run it. As you can see, route is calculated for driving from Ankara to Istanbul because we give it as default route algorithm, but we can change it with setter, set route algorithm, and new, let's say, flight. Now we can get another route, and let's say Ankara to Elazığ, and run it again. Okay, first one is driving Ankara to Istanbul, and then we changed the route algorithm in the runtime, and now we see the flight route from Ankara to Elazığ. So this is the strategy design pattern. Thank you for watching. Have a nice day.